So now we'll be studying what is object-oriented programming. Okay. So object-oriented, the name itself tells you that everything is oriented towards objects. Okay. So let me say that I am declaring an integer. So here the type of this particular, the data type is nothing but a class of int. That means it is a class. Okay. As discussed in the previous videos, object-oriented programming, what we are going to do is that we are going to create a data type of our own, which will have certain features. See, this is int. This is a class of integer. So you get it as int. Right? So the characteristics of integer is already defined inside the Python interpreter. Now I'll show you a very simple example. I'm going to create a class called as student. Okay. So what are the features that students will have? A roll number, right? A roll underscore number. Okay. Is equal to, say, an empty string. Name. Another empty string. Okay. So student is a class, is a variety of people. You are creating your own data type and you are defining the characteristics of a student as per your wish. Should have a class, right? But class is a keyword, so you can't use class. We can use a section or something like that. Okay. Section, say you call it as, if it is your class, I can call it as S3 ECE. Okay, I'm calling it as S3 ECE, for instance. So by default, whenever I create a student, the student will have a class variable and that class will have S3 ECE as its value. Same thing, by default, a student will have a name that is empty, a roll number that is empty. Okay. This is, I am defining the characteristics of a particular, a type of, a group of people or a group of things or group of, an object is nothing but a group of things or a group of, which is having some common characteristics. I'll give you more examples for you to understand better. Now see, next, this is the way I created a class. Now what I'm going to do is that I'm going to create individual students. That will be instances of the class or the objects of the class. Okay, so here I'm creating somebody called as Lakshmi and I am making it to be a student. Okay, better I'll use the word students because let it be in plural for you to easily understand. So what here we are doing, we are telling the Python interpreter that Lakshmi is a student. I can create the next student. Okay. I can create the next student like that. And I can access each individual student. Say Lakshmi dot section will return to me S3 ECE as the output. I can change Lakshmi dot name is equal to Lakshmi Lakshmi K, and I can say Lakshmi dot name. When I print, I'll get Lakshmi dot name as Lakshmi K. So student is a general set of characteristics of a particular type. Okay. And the other ones are each individual types, individual instances of that type. But you can override all these things. You understand? You can override all these things. Override means you can change any of these characteristics as you like. Okay? I'll give you another example. Let us create a class called as animals. All animals will be having certain characteristics. Generally, what will be the characteristics? We'll say 2-legged, 3-legged, 4-legged, 5-legged, and so on, right? So, number of legs can be 1. Number of legs. Okay. Let me give the default value as 4. I am giving the default value as 4. That means I can have animals with more than or less than 4 also, but when I create an instance, I can change it according to however I like. Is that clear? This is only one feature. You can add as many features. The color of the skin, color is equal to, say you can put brown, for example. Okay. And I can create, say for example, cat is equal to animal. And when I print cat dot color, I'll get brown. Sorry, it is animals. Animals. So I'll get cat dot color, I'll get it as, okay, animals is not defined. I'll get it as color as brown. So object oriented programming means you are creating objects based upon a group of certain characteristics. Okay. Now I can create another one. I can inherit one class from the other. Say I can create a new class called as cat, which inherits animals. And I'm giving pass. I'm not giving anything inside that. Pass means it is simply empty. Now I can run this. Right? Now it is perfectly right. Now I can create an instance of class, my cat. Is there anybody in this class who has a cat at their home? No. I'll call the name of my cat as Johnny. Okay, some name. Johnny is equal to cat. This means I declared Johnny to be a cat. Now, Johnny dot color. What should be the value? I'll get it as brown. Okay. I can edit it also. I can edit it also. I can give Johnny dot color is equal to white. And now when I print the spelling, okay, Johnny dot color, the color of Johnny will be white. The color of Johnny will be white, but the number of legs that Johnny is having will be the same one. Okay. Johny, Johnny dot number underscore of underscore legs. Now this will be the same 4. This is called as inheritance. Object oriented concepts, I am inheriting one class over the other. There are so many examples. I can give you one more example. I am creating a class called as vehicles. I am creating another class called as vehicles. Okay. Number of wheels, no underscore wheels is equal to say 4. Okay. So the number of wheels is 4. Now I can create another class called as bike, which inherits vehicles. Okay. Yes, any doubts? My bike is equal to bike. I am creating my bike instance with bike as a variable. Now bike will have only 2 wheels, right? So what I can do, my bike dot no underscore wheels is equal to 2. So my bike dot number of wheels, I'll get it as 2. Sorry, I'll get it as 2. I can here also I can declare my no underscore wheels is equal to 2. That means I have overridden the values. But rest of all the characteristics are inherited already. You understood? All of you. Now I'll give you another example where we are going to create some methods. I'll teach you how to create methods inside the class. Or one more thing I can do here. When I was creating these names, okay. Listen here, I'm coming back to the previous example. Here I have created a class of animals. I have inherited these animals. I have inherited these animals. So here I have created a class called as animals. Then I am going to create a class cat, which is inheriting all the features of animals. Okay, so here I'll be declaring, for example, I'm giving you some example, I'm declaring something called as name. Name is empty. No name is there. Okay. Then listen carefully, I'm going to create a method, and this method is a built-in method. I'm going to overwrite a built-in method underscore str. That means a string. I'm creating a string class, and what I'm doing is that I'm inheriting self and then name, or self alone is enough, and then return self dot name. So whenever I have the instance of this class, it is going to return the name of the cat. Okay. So now I am going to name this cat. Okay. Let Johnny is an instance, or let it be C is an instance. C is equal to a cat. Okay. I'm creating a cat with name C. Okay. C dot name is equal to Johnny. Right? So I've created a class instance of this cat object, and I've defined the name of that object to be Johnny. That's all. Now if I simply use this C, what is it going to return? It is going to return an object. No, I have not returned this. Yes. I have not run this, that's why I am not getting errors. I'm getting errors. Returning the So here I have inherited animals to my cat class. I have declared here name Johnny. Okay, I can give it empty also. Okay, and I have used this def underscore underscore string self string method. Okay, this is a built-in method inside Python which helps us to return a human readable form of an object. Okay, for example, I'll let you know that. Now I'm not having this here. I'm just removing this. I'm creating an instance for cat as C, and I am running this. When I run this, I'll get the object not interested, move out. Otherwise, listen here. So here I am getting an object instance here written, but I want this to be in a human readable form. So what I am going to do is that I am going to use def underscore underscore str underscore underscore and self, and whatever this returns is what will be printed here. Okay. Now what happens? Now the empty string will be printed here. No, nothing will be printed. Empty string will be printed here. Okay. Now if I declare C dot name is equal to Johnny, name is equal to Johnny. Now it will return Johnny here. Understood? This is to make, suppose you wanted to return, that is human readable form. Wherever you want to access, if you get the object instance, it is very difficult for you to access the program. In order to make your program accessible by human beings, very easily readable, we use this underscore underscore string method which inherits the same class. Self means you are inheriting the same class. Is that clear for all of you? Understood all of you? Any doubts? Clear? Are you all clear with the fundamental object-oriented concepts? Is there anything that you want me to repeat? I'll repeat now. Do you want me to take anything once again? I'll do it now. But don't tell me after a few sessions I did not understand anything previously, which I cannot do it. Now is the time for you to lay a foundation. So if at all you have not understood, tell me about that. Understood all of you? Clear? Okay. So vehicle is a class. Buses could be a class or could be instant. Your college bus could be an instance of the bus class. Bus class could be a major class which inherits all the vehicles. Okay. Vehicles can have number of wheels. But if you have a helicopter to be a vehicle, we can give number of wheels to be 0. That is also possible. So a class in general, an object will have a certain character, certain features that is listed among itself. Right? These features can be overridden also. Okay. There can be a student who never comes to the class, so he does not have any class. But we don't consider that. But in general, all students have classes. If there is a student which does not, see, all cats have 4 legs. Right? Suppose your cat has broken one of its legs, it's still a cat. You can override the number of legs to 3, that's it. Understood? All of you understood the object-oriented concepts? At least the inheritance and object-oriented concept. We'll have so many other features like abstraction, polymorphism, data encapsulation. That means you can cover up data. All these things are extremely useful when you do real-time projects, and I'll be teaching you one by one with examples. As of now, you are clear with these concepts, right? Is there any doubt in object-oriented concepts? Is there anything you want me to repeat? I'll do that. So thank you now. Now you can start